All right, so we just finished this example. I've got three more, and they'll be pretty similar to what we just saw on this last one. So right here, first thing we want to do is the leading coefficient test so we can figure out that behavior. So there's going to be some ups and downs, but we want to figure out what happens to the right, what happens to the left. And so that's going to be dependent on the term with the highest power. And so the leading coefficient's negative. That's going to determine the right hand behavior. So as I plug in larger and larger positive x values, I'm going to get negative values in return, which are my y values, which cause the graph to go down when you graph it on the xy plane. Then the power is even, so the left end behavior will actually have the same behavior. So it's going to fall in both directions, left and right. So let's see, falls to the left. Let's see, Oh, it was the first one. Here we go. Falls to the left, falls to the right. Okay, now we have to find the x-intercepts and then figure out the multiplicity and figure out what that's going to look like on the graph. So what we'll do is we'll take negative 3x to the power of 4 plus 27x squared. And we're going to set that equal to 0. And then what I'm going to do is I'm going to factor out a negative 3x squared. And so let's see, that'll leave me with x squared minus 9 equals 0. And then we can go ahead and factor this as the difference of two squares. So that means I can rewrite that as x plus 3 and x minus 3. And so I have three x-intercepts. So right here, that's going to be 0. That's going to be negative 3. And that will be positive 3. Those are the three values that will satisfy this equation. Those are my x-intercepts on my graph. So you got to be careful down in this part because they want us to list right here. It says we want to find the multiplicity of the least x-intercept. So you got to look at the smallest value here, which would be negative 3. And its multiplicity has an understood 1 right there. Then it says list the multiplicity of the greatest x-intercept. So the largest value is positive 3. And that one has a multiplicity of 1 also. Then it says, if there are any others, then go ahead and list it. If not, you would put that does not exist there. And so we do have another one at 0, but this one actually has a multiplicity of 2. Okay, so then this next part, we're going to do the same thing again, but now they want us to get a little bit more descriptive on our multiplicity and state whether it crosses or touches. And so once again, it's going to be the same order, the least, the greatest, and then if there's any other ones. So my least one right here, negative 3, since it's a multiplicity of 1, that means we are going to cross the x-axis. Then for my greatest one, 3, also it's going to cross because its multiplicity is 1. Then my last one, my other one that's in the middle, 0, that one has an even multiplicity, so that means we're going to touch, and turn around. And so there we are. All right, so now the next part, they want us to figure out the y-intercept. So if I were to plug in 0 into the function, if I were to plug in g of 0, everything would zero out here because everything has the x there. And so if I plug in 0 for x, everything's just going to zero out. So my y-intercept's actually going to be at the origin. And so that's going to be at 0, 0. Then it asked if it's even, odd, or neither. And so I said most of the time it's probably going to be neither, but let's look at this one. This one actually is going to end up being even. And the reason why is because all my powers are even and I don't have a constant on the end. So for example, if I had something like a plus or it could be minus, it doesn't really matter, like 10 on the end, then this would actually fall, um, or actually I'm thinking of the odd ones. Actually, it would not make a difference. But for odd ones, it does make a difference if you have a constant on the end. So actually, we'd actually be okay even if I had something. Either way, if everything's even, then you're dealing with the even function. And so what does that do for us? Well, that means that we're going to be we're going to have symmetry with the y-axis. So whatever I have on to the right, I could reflect it over to the left side of my y-axis right there. Okay, so what we're going to do here is we're going to take the information once again, and from that, we'll go ahead and make a little rough sketch. And like I said, on the homework, you'll have multiple choice, so that'll make your life a little bit easier. Okay, so I grabbed my behavior, my end behavior, and then I also grabbed where my x-intercepts are, and then knowing the multiplicity. So I know that multiplicity of 2, it's either going to kind of dip down and hit or maybe peak and bounce off. And then the multiplicity of 1s are going to basically look like straight lines as I hit the x-axis for the most part. So let me go ahead and plot all my x-intercepts. So let's see, I have 1 at -3. I have 1 at 0, and then I have 1 at +3. Okay, now I know my end behavior that's going to fall in both directions, and both those x-intercepts are going to be, they're not being bounced off. So if I want to, I can go ahead and kind of already start to draw that like this. It's going to just kind of go straight down like that, a little bit to the left and a little to the right. So then it looks like I'm going to come up and then I'm going to bounce off. Remember, I bounce at the 0 because my multiplicity was 2. And so you can't, like I said, at this point, you should be able to kind of figure it out from the multiple choice. But if you want to be a little bit more accurate, what we could do is we could plug in 1 and 2, and it would be the same for -1 and -2. So let me give myself a little bit of space here. And I'm actually, this is the factored form right here, but this would be pretty easy if I plug it in there. So what I'm going to do, so I'm going to figure out f of 1. So what I'm going to do is I'm going to have -3 times 1 squared, and then 1 plus 3 times 1 minus 3. So I'm plugging it into what I have written in red here. It would be the same thing as if I were to plug it into this. And if you wanted to, you could plug it into the original. Okay. But what I'm doing here, we're actually going to do this in a later section in this unit. So it's kind of good for you to see it now. So let's see, this should stay -3. 1 squared is 1. 1 plus 3 is 4. 1 minus 3 is -2. When we multiply all that stuff together, let's see, what are we going to get here? We're actually going to get 24, so that goes up pretty high. And so, by the way, that's the same as if I were to plug in -1. I would also get 24. And if you don't believe me, you can try it. Okay, so I know that this thing's going to go pretty high up. Let me do one more point. Let's figure out f of 2. So let's see, we'd have -3 times 2 squared, and then 2 plus 3 is 5, and then 2 minus 3 is -1. So we're going to end up with 3 times 4 times 5. Yeah, that's a -3. So let's see. Oh, wow. This is actually going to turn out to be 60. So that's going to go pretty high up. And so what we want to do here is just scale this, and that should make things pretty easy. So we can go by 20s or whatever. So let's see, 20, 40, 60. And I'm just going to label the 60 up here. And so let's see. At 2, I need to be all the way up here at 60. And at 1, I need to be at 24, so a little bit above my 20 mark. And then, like I said, -1 will be the same, and so will be -2 will be the same as +2. So you can just kind of reflect those across the y-axis. And so we'll come up here, just try to do it with a smooth curve. Like I said, on your homework, you're just gonna be picking from multiple choice graphs, but it should be set up the same way. It'll be scaled for you like that. All right, I think I've got 2 more of these for us to check out. So here's another one. And so we start by looking at the term with the highest power. That's going to help us determine its behavior. So we know there'll probably be some ups and downs. But to the right, let's see, since it's negative to the right, it's going to fall. And since it's odd, it will have the opposite effect to the left. So it's going to fall to the left, no. Rise to the left, yes. Rise to the right, no. Falls to the left, no. Rises to the left, falls to the right. There we go. That's one we're looking for right there. Then now it's time to find those x-intercepts. So we're going to take this, set it equal to 0, and factor. So I can factor out an x squared, but I'm also going to pull out the negative. It will just make things look a little bit nicer. So then let's see, this will become x minus 3 right there. That's my leftovers. And if you were to distribute it back in, it's just the same thing I have right above right there. But we want to leave it in factored form. And so my first x-intercept right here is at 0, and it has a multiplicity of 2. And then my other x-intercept is at 3, and it has a multiplicity of 1 right there. So once again, now we take this information and we're going to fill this out right here. So my smallest one was at 0, and we had a multiplicity of 2. My largest x-intercept would be the 3, and that had a multiplicity of 1. And then as far as others, I don't have any others, so I believe in the directions it says to put the does not exist right there. So we don't have to worry about that. All right, and so then how does it look on the graph? Well, for my x-intercept at 0, I have a multiplicity of 2, so it's going to touch. Okay, touch or bounce off, right? And then for my larger x-intercept at 3, it's going to cross because I have a multiplicity of 1. So it's going to cross right through it. And then once again, we don't have anything for that. And then you might have that same option for the drop-down window here. I'm not sure. You'll have to play around with it. Then for my y-intercept, we do f of 0. You let x equal 0. And when you plug in 0, once again, everything's going to get zeroed out. So when x is 0, y is 0. So that's going to be my y-intercept, because by definition, you let x equal 0. So when I did that, y equaled 0. So that's just right there at 0, 0. And then even or odd, well, you notice I have an odd power and an even power, so it can't be either of those two. Okay. So there's not going to be any symmetry with the y-axis. Odd functions have a symmetry of a rotation of 180 degrees. And so anyways, I wouldn't worry too much about that. Like I said, most of these are going to fall under the neither category. So then once again, we'll use the information from above to go ahead and graph this. Okay, so let's see, I have an x-intercept at 0 right there at the origin, and then over 1, 2, 3, I've got one right here. Now, my behavior is I'm going to rise to the left and falls to the right. So to the right, I'm going to fall. Now, at that x-intercept, it's a multiplicity of 1, so it should be pretty much like a straight line, kind of like that. But then my multiplicity at 0 is 2, so it's going to kind of have that parabola shape as I hit it. So we know that it's going to rise to the left. So it's actually going to look something like this. You kind of want to curve into it. You don't want to be such a straight line. So it's going to bounce and then go up from there, right? It's going to bounce, go up, and then come back down like that. And honestly, that's probably good enough for you to figure out what it is from the multiple choice graphs. But I'm going to go ahead and just figure out what f of 1 and f of 2 are, just so I can make sure I'm pretty accurate here. So I'm going to give myself a little bit more space. So once again, I'm going to use this as my function. So f of 1, I would have negative 1 squared and then 1 minus 3. Well, this would become negative 1 times negative 2, which would become a positive 2. So at f of 1, I'll be up 2 spots. Let's go ahead and figure out what f of 2 is. So let's see, that would be negative and then 2 squared times 2 minus 3. So I'm going to get negative 4 times negative 1. And so I'm going to be at positive 4. All right, so let's go ahead and I'm going to put that on my graph just to make it a little bit more accurate now. So let's see. All right, so we're going to go up 1, 2, 3, 4 spots. So at f of 1, I'm at 2, and f of 2, I'm up here at 4. So my graph Just kind of, it swings back up like that parabola shape, but then kind of once again makes another parabola shape and comes back down like that. All right, one more to go. Okay, so this one, let's see. So we're going to look at the leading coefficient. It's positive, so we're going to have our ups and downs, but since it's positive, I'm going to go up to the right. And since it's an even power, I have the same behavior to the left. So it's going to rise both ways. So we're going to rise to the left and rise to the right. Now, time to figure out our x-intercepts and go ahead and list their attributes. So we'll set this equal to 0. I'll start by factoring out an x cubed, and I'm left with x plus 3 equals 0. So I have two x-intercepts. I have one at 0, and I have one at -3 with a multiplicity of 1 right there. So this one's going to be kind of similar to the last one that I only have two x-intercepts. So let's see, the least one, the smallest number that I have here is -3 for my x-intercept, and that has a multiplicity of 1. And then my greatest one's going to be at 0. That's the largest between the two x-intercepts. And that one has a multiplicity of 3. We haven't seen that yet. We've seen it, but we haven't had to graph it yet. And then as far as other, we don't have another one, so it does not exist. We do not have a third one. And then down here, now we need to kind of describe how it's going to look. So for the -3 x-intercept, it's an odd. If it's odd, it's going to cross. Okay. And then at 0, it's also still odd, so I'm still going to cross the x-axis. And then I don't have a third x-intercept that I have to worry about. All right, the y-intercept, I think it's the same as the last couple. So yeah, so if I were to plug in 0 into the function, I'm just going to get a 0 in return. So I'll go ahead and put that down here. So that ordered pair is going to be at 0, 0. And then once again, it's neither odd or even because I have an even power and an odd power, so automatically it's going to fall into the neither category if that's the case. And now it's time to take the information and go ahead and do a rough sketch. All right, so let's see. We have a x-intercept at the origin and then at -1, 2, 3. So over here. And I know that it's going to rise to the left and to the right. Now this is where it's going to get a little tricky. So we've seen this, but we haven't had to graph this yet. Whenever you have a multiplicity of 3, it's going to kind of have this effect to it, or it could go the other direction. It could be coming down like this. It's going to have that cubic shape to it where it hits the x-axis, so we need to keep that in mind. So let's start on the left side, though. So at -3, I have the multiplicity of 1, so that's going to be more of like a straight line, right? And so I'm rising to the left, so this is just going to kind of be, oh, let me do a different color. Let's do red. All right, so this is just going to kind of come through here and cut through, and it's going to come down and somehow come back up and then go through right here at 0. And so at 0, I have that cubic shape. And so I'm going to rise to the right. So it's going to kind of come out of that cubic shape and kind of almost like a half of a parabola opening up. But then the other half is going to be kind of coming down like this. So once again, this is just kind of a rough sketch right here. And that's probably good enough for you to figure that out on your homework. But once again, I'll just go ahead and figure out what is f of -1 so we can see this. So let's see, -1 to the power of 3 times -1 plus 3. Well, -1 to the power of 3 is going to stay -1. And -1 plus 3 is 2. So I get -2. So at -1, when x is -1, y is -2. So we'll put that about roughly right there. And then let's see what f of -2 is. I'm kind of curious. Let's see. F of -2. Ooh, this is going to be a lot bigger. Okay, so let's see. -2 cubed times -2 plus 3. Well, negative 2 to the power of 3 becomes a negative 8. Negative 2 plus 3 is 1. So we get negative 8. Not huge, but it actually does dip down further than I was expecting. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So that's way down here. So once again, on your homework, they'll probably scale it to where maybe it won't be so dramatic of how far down it's going. So we come down here, come back up. So they might scale it a little differently. And so, let me see. So when I come up, I need to kind of come curve into it from like left to right like that. There we go. It's probably a little bit better. All right, so that concludes 3.2. We're graphing our polynomials, specifically our higher ordered polynomials. And so if you have any questions or concerns, just let me know.